Alright, today we're doing matrix powers. So when you have a matrix to a power, so it's pretty much saying like the same thing. If you have matrix A squared, it means matrix A by matrix A. But you can only use a power in a matrix if the matrix is square. So remember, what do we mean by square? They would be the same rows as columns, so maybe a 2 by 2 with a 2 by 2. Alright, so when we look at powers, so it can only be a square, so that can save you in a multiple choice to be quite quick. If they said, you know, what's the answer to this, make sure you just eliminate anything that's not a square matrix. And the other thing to look at, when we have something to the power of 0 in normal maths, it's always 1. So say 3 to the power of 0 is 1, 4 to the power of 0 is 1. When you have a matrix to the power of 0, you can see you get, what do you get? The identity matrix. Remember I said the identity is like a number 1. So that's the identity matrix. So all these little things can just help you be quicker. Now, you don't ever have to do matrix powers manually in that. If you see them, you simply will do them on your calculator. So up here in these examples, if we go through it, it says here, find matrix A to the power of 0. Well, I'm not going to bother entering that into the calculator because I know, because I just told you, that you should get the identity. If the matrix was a 3 by 3, then you'd get a 3 by 3 identity matrix, yeah? Does that make sense? But A is only a 2 by 2, so that's why I'm doing that. Now, so here, sorry, it's a little bit small for me, but if you have a quick look there, I've done A to the power of 3 on the calculator. So you still just do the same in terms of the button, you just raise it to the power. Type the matrix, raise it to the power. So if we go and do these other ones, you would simply just be doing them in your calculator. I'll pop them up, the answers, in a minute, but I won't go through that now. So multiply, we're going to take note 2 over here. Multiplication by the identity matrix gives the same matrix. We've already looked at that. Remember I said because it's like a number 1, so if you multiply it, you get the same one, and we just showed that. So that's just a repeated fact there. All right, now we're also going to look at binary matrix as well today. So binary matrix have only 1s and 0s. So can you see here, we've only got 1s and 0s and that. All right, so a binary matrix has 1s and 0s. Now a permutation matrix is a binary matrix. So it does have only 1s and 0s, but it's a particular one where it only has 1 in each row and column. So can you have a look here? If I look at this column, there's only 1, and if I look at, say, this row, there's only 1. So that's what makes it a little bit different to a permutation matrix. If you look up here in just a binary, up here there's more than 1 in that column. So it's a binary matrix, but not a permutation matrix. So a permutation matrix is sort of is an identity matrix with, well, it looks like an identity matrix. But anyway, we use it to rearrange another matrix. So if you have a look here, we're going to have a look, and you can see that they've got this matrix here that has TAR. So it is a 3 by 1. So it doesn't matter that it's got letters, it's just got numbers. It doesn't have numbers, that's okay. But we're going to multiply it by this permutation matrix, which is a 3 by 3. All right, so obviously they have to put the P matrix first because otherwise it wouldn't be defined, as we've looked at before. So when we do this, you'll watch out and see we multiply it by this permutation. Can you see that the answer, see how the letters have been rearranged? Now R is on the top, now A is on the top, and now T is on the top. So a permutation matrix will shuffle the other matrix around. Now, you can do it again. So here they've squared it. So that means they're timesing it twice. So you can see it'll move the letters again. And so if you times it twice by the permutation matrix, you see the letters adjust. All right. So what you need to do though, sometimes these questions are easier if you know how to manually multiply, because you can quickly move it in your head. And I'll show you that, I'm sure, in this next example. So here's an exam question with a permutation matrix. So why is it a permutation? Can you see in that row there's the only one, yeah? If I went down any column, I'm only going to see 1, 1, and so on. So this is a permutation matrix. All right, it's being multiplied against this letter matrix, and they want you to do is equal to. Now, can you see, when you multiply matrices, remember we're going to go run and we go dive. So could you see if I wrote that first one out, so remember our answer is going to be because this is a 5 by 5 and this is a 5 by 1. So our answer, which we should know because it's a permutation, is going to be the same, 5 by 1. Now you can see if I was doing that first row, it would be 0 times L plus 0 times E plus 0 times A plus 1 times P plus 0 times S. So can you see that this P, is what's going to show, because everything times by 0 is 0, isn't it? So here, you're going to have the P is going to show up here first. So you can just pretty much go, all right, 1, 2, 3, 4, and you go down 1, 2, 3, 4. Wherever the 1 is in that row, that's the letter that's going to show. So if I go along here, 1, 2, 3, what letter's going to show? 1, 2, A, yeah? So I put an A there. So then you go through, what's your answers? Already, this is the only one, yeah? With that combination at the moment. So I'm just going to go with that and move on. All right. So question 4, matrix P is a 4 by 4 permutation matrix. Matrix W is another matrix such that the matrix P and W is defined. The matrix product results in the entire first and third rows of the matrix W being swapped. The permutation matrix is. So we're going to have, if we've got the permutation matrix and we're multiplying it by W, and we're going to get this new answer. Now this is a 4 by 4, so this must have been a 4 by 1, yeah? So, and our answer will be a 4 by 1. All right, so what you could do is you could just put, you could make up a 4 by 1 if you wanted, you know, something with 4 letters, even just write A, B, C, D. And what you want to do is when you multiply it, it says the results within the entire first row and third row being swapped. So really, that means I want C, B, A, and D. Does that make sense? I've swapped the first and third row. Does that make sense? Yeah, that's what they're trying to ask you here. So, just to repeat, they wanted me to, the result, so the result, which is here, want the entire first row and third row of matrix W being swapped. So that means this is row 1 and this is the third row. They want them swapped. So in my answer over here, I'd want to see C and A in the different positions. All right. How did I know that matrix W is a 4 by 1? Because it is defined, so I know it definitely has to be a 4. And we're just, normally they're just a column matrix when we're swapping them. So you could just give it a go. This is going to work. So let's have a look. If we go along here, if I went run, if If I went run and then dive down here, the first letter that's going to show up is a D. Do I want that? No, so I'll cross that out. What about this one? If I ran across here, dive down here, that works, yeah? Now let's see, what would I get the second? Would I get a B? Yeah, that's good. And then I get an A, that's good. And then I get a D. Does that look good? Yeah, let's go with that as the answer. Check the others later in your exam if you've got time. Or this would be one I might come back and trial my answer. So say I found this, I might put that in the calculator, times it by my matrix that I had there, the ABC, and see if I get what it says. So that's a different way to check. Now you can put letters in the calculator, it will work. It'll just adjust them around. Like a number, just put the letter in there.